Let's take a look at this electricity question. A battery with an EMF of 22 volts is connected to 3 resistors and an electrical device as shown in the diagram. The connecting wires and battery have negligible resistance. The voltmeter reads 8 volts. 5.1 says define the term current in words. So 5.1, we can define current as the rate of flow of charge. Question 5.2, calculate the reading on ammeter A1. So ammeter A1 is reading the current in this branch right here. To calculate the reading, we can use the equation from Ohm's law. And the equation says that R equals V over I. Now to work out the current reading, we can substitute a resistance value and a corresponding potential difference or voltage value. Now what can we substitute? If you look at this branch, we have a 4 ohm resistor and we know the potential difference across that 4 ohm resistor. So we can use that pair. We can say that 4 is equal to 8 divided by I. Then solve for I is equal to 2 amperes. Next question says 3000 joules of energy is transferred in the electrical device in 1 minute. Determine the charge traveling through the electrical device in 1 minute. Now to calculate the charge, remember charge is Q. So we want the Q value. Now to calculate the Q value, we can use the equation V is equal to W over Q. We've been given the W value of 3000. We want the Q value, but we don't yet know the V value. So it must mean we can work it out somehow. And to work it out, what we can do is we can focus once more on this green branch. We can work out the voltage that green branch is using in total. We can use the formula V is equal to I times R. The current we worked out is 2, and the resistance in that branch is 4 plus 2, 6. So 2 times 6 is 12 volts. So what does this mean? It means that this branch right here is using up 12 volts in total. It means that this branch right here will also use 12 volts because those branches are in parallel. We don't need to worry about the top branch right now. What's more important though is that we can work out the voltage for the device, because this 12 plus the device must give us the 22. So the device will be 22 minus 12, which is 10 volts. Now that we know the voltage, we can substitute it into our original equation here and solve for Q. Q is going to equal 300 coulombs. Next question, 5.3.2, calculate the reading on ammeter A2. Now, what is A2 reading? Ammeter A2 is reading the total current of the circuit. Now, what information do we know? If we focus on the device, we know the charge going through that device is 300. We also know the time, which is 1 minute or 60 seconds. Now to calculate the current that's passing through it, we can say I is equal to Q divided by T, 300 divided by 60, which is 5 amperes. And remember, this is actually from the definition in 5.1. Current is the rate of flow of charge. So charge divided by time. And the last question, question 5.4. The switch is now opened. So if the switch is opened, it means that no current is going to go through this top branch. It means that my circuit is now just this. This top part is now gone. So what happens? They want to know what happens to the total current. Will the current through the device increase, decrease, or remain the same? And explain. So remember the following. If we remove a resistor in parallel, the total resistance will increase. I know it sounds counterintuitive, but you can test it using calculations. So if you remove a resistor in parallel, the total resistance in the circuit will increase. Now, resistance is inversely proportional to current. So if the resistance increases, the current will decrease. And that's our answer. Thanks for watching. Don't forget to like, share, and subscribe. I'll see you in the next video. Bye.